When we think of pollution, we think of foreign countries such as China and India. In reality, we have one of the biggest steel industries here in North America, right in our own backyard. The business has brought prosperity and identity to the city of Hamilton and was established over 100 years ago. But how has it affected our nature? Air pollution affects more than just the third world. By 2050, air pollution will become the biggest cause of premature death, killing an estimated 3.6 million people each year. Hamilton, Ontario is Canada's 9th largest city with a population of over 520,000. The city is divided geographically by a 90-meter escarpment, and the economic boom from the steel industry has made it a hotspot for air pollution research. There are up to 40 mobile recording stations for pollutant levels in Hamilton, Ontario. We have extracted the data and found drastic correlations. In a time series analysis, we found that over the past 10 years, all pollutant levels have increased. Nitrogen oxide, sulfur dioxide, particulate matter, carbon dioxide, and carbon monoxide were explored. And after the data was stratified, we found a correlation between pollutant levels and weekly mortality data. We found a statistically significant relationship between the two, and we further looked into the health effects that could be the cause to this qualitatively.
Carbon monoxide is one of the deadly pollutants as it is colorless, odorless, and can alter the ability for red blood cells to carry oxygen. The health effects of carbon monoxide differ depending on the duration and concentration of exposure. Some symptoms include headaches, dizziness, and weakness. Ozone is formed through a chemical reaction with nitrogen oxides and other organic compounds. There are two levels of ozone. The upper level of ozone protects the Earth from harmful UV radiation. However, the ground level ozone is a highly reactive gas that can be dangerous for our health. Ozone causes a muscle in the airways to constrict, trapping air in the alveoli. As a result, high concentrations of ozone causes shortness of breath and pain when inhaling. Studies show as concentrations of ozone increase, so does the number of respiratory admissions in hospitals across Ontario. Nitrogen dioxide is another deadly pollutant as it contributes to the formation of photochemical smog. Through a chemical reaction, photochemical smog produces a brown haze. The brown haze consists of small particles which can be detrimental for human health. A lot of the nitrogen dioxide here in Ontario originates from the transportation sector, which includes highways and road vehicles. Some of the effects on human health include irritation of the mucosa in the eyes, nose, and throat. However, long-term exposure may reduce an individual's lung function. Sulfur dioxide is a pollutant generated when fossil fuels are burned. Ore smelling, coal-fired power generators, and natural gas are all examples of industrial processes that produce sulfur dioxide. Some health effects may include irritation to the eyes and nose, bronchoconstriction, and increased asthma symptoms. There is also a connection between exposure to sulfur dioxide and hospital visits. Fine particulate matter is a term used to describe the mixture of small particles and liquid droplets in the air. Some examples of particulate matter are smoke, dust, ash, and pollen. Of all particulate matter, the greatest health concern is from the particles that are less than 2.5 microns in diameter. These particles are so small, they can only be detected using an electron microscope. Long-term exposure to these particles can lead to lung and heart conditions and have been linked to an increase in mortality.
To get a better understanding of the pollution in Hamilton, we met with Dr. Matthew Adams, who is a specialist in spatial analysis and modeling.
Matthew Adams. I did my PhD here at McMaster in the School of Geography and Earth Sciences. Specifically, we looked at trying to improve the estimation of exposure for people and trying to take it from exposure on an annual basis and trying to estimate it in shorter intervals to assign the exposure to the pollutants as people travel throughout their day. Because relating it to Hamilton, for example, you could have someone who is, say, a manager at the steel plant, spends 8 to 9 hours a day during the week at the steel plant, or maybe more than that, where they're being exposed to very high levels of contaminants. And then the rest of their day at their household, they may be spending it in Ancaster, where the air pollution is generally fairly low. So if you were just simply to look at their household exposure, it's not going to really tell you the true story of what's going on with that person. So my work is trying to take that And not just at those two locations, but understanding as a person travels when they're on the highway, when they're doing their errands, understanding what their exposure is. Yeah, you know what, we do have, significant numbers, probably a few hundred early mortality issue people. However, air quality has improved in Hamilton, definitely, drastically actually, but we're starting to see it rising again because of congestion and just the number of commuters that we have in the region. So we've seen a shift from what used to be an industrial pollution issue that really improved, and then it was static through the early 2000s, and now we're starting to see a rise of vehicular related pollutants in the area. Cycling infrastructure, active transportation. We have electric vehicles are on the horizon. They will solve a lot of our local issues as we reduce the emissions from the end of tailpipe. But in the next 10 to 15 years, the more people we can get commuting via active means and taking public transit is just going to drastically improve air quality, especially in those congested regions.